Hello everyone, welcome to the channel Code Like Him. Let's see today's problem. It is 401 binary watch. So a binary watch has 4 LEDs on the top of to represent the hours 0 to 11. So it means it has 4 LEDs 1, 2, 3, 4. These 4 LEDs and it represent 0 to 11 hours and 6 LEDs on the bottom to represent the minutes 0 to 59. Okay, so it has the bottom LEDs are 6 LEDs 1, 2, 3, 4, 5, 6. Okay, and it represents 0 to 59 number. Each LED represent a 0 or 1 with the least significant bit on the right. Okay, for example, the below binary watch reads 451. Okay, so let's say we have these 4 LEDs, and in this LED, the fourth, the 1, 2, 3, the third bit from the right is set. Okay, and the binary, these are the binary representation. So the first bit is set, it means it is 1. If the second bit is set, it means it is 2. Third bit is set, it is 4, and the fourth bit is set, it is 4. It means 8. So the this bit is set, it means 4. And to represent 51, we have binary configuration like 1 1 0 0 1 1. So it represents this 451. Okay, so given an integer turned on which represent the number of LEDs that are currently on, ignoring the PM. So it doesn't mean PM or AM, we just need to ignore it. Return all the possible time the watch could represent. You may return the answer in order. Okay, the R must not contain a leading 0. For example, if the R is 1, so we don't need to do 0 1, it should be 1. The minute must consist a 0 digit and may contain a leading 0. For example, if there is 2 minute, if this bit is set only, then we should represent it like 0 1, not only 1. In this case, they have given the example of the minute is 2, so we need to represent it like 0 2. Okay, so what we are in this question, we have been given an integer turned on. It represents the number of bits that are turned on in all these 10 bits, 4 bit for hours and 6 bits for minute. And these there are only 4 bits for hour because the 11, which is the greatest number, will be represented in the 4 bits, and the 59, which will be the greatest among the minutes, will be represented inside this 6 bits. So the 4 will be for hours, and 6 will be for minutes. Okay, so we are given an integer turned on, and it represents the number of bits are set, whether it will be turned on in this hour section or for the minute section. And we need to return all the possible the timings which will be valid if this turned on is if this number of bits is turned on. Let's see, the turned on is 1. So we can place any we can set any bit out of these 10 bits. Let's say if I choose this bit, the first R bit, so the time will be 1. Like in this square that they have given, the time will be something like this 1. So minutes will be 0, the time will be 1. If I choose this, the time will be 2, like this. And if I choose this, the time will be 4. And if I choose the third bit, the time will be the fourth bit, the time will be 8. The third bit, sorry, the time will be, let's see, 1 2 3 4. The fourth bit, the time will be 8. If I choose minutes, in minutes I choose this, the time will be 0 0 0 0 1, something like that. So what we can do it is, since it is an easy categorized problem, what we can do is, we know the ranges of hours and minutes. What we can do is we can iterate over all the possible values of hours and all the possible values of minutes, and we can check if this current number we are standing on, how many bits are set in this current number. Let's say in this range I found something like this number 2. I got 2 number, 2 for hours and 0 for minutes. Then I will check if this 2, what is the bit set count in 2, and what is the bit set count in 0 minutes. So if this bit set count is equal to the addition of these two will equal to turned on bits, then I can say that it is a possible answer and will insert in my result variable. Else I will iterate over that. I will find the next possible value. I will look for the next possible value. Okay, so the simple code is to count the bits, I will simply use count bits. I will iterate over every bit and check if it is set or not. And for all the possible values of hours, I will be iterating this hours for 0 to 11 and for minutes for 0 to 59. And I will check if the count of set bits in hours and count of set bits in minutes is equal to turned on. If it is true, then this is my answer. But in the question we are given that if the minutes is something like 01, let's say something like here, for example, something they have said about if the minute is like something like 2, then I need to return 02 in the result. So I will check if the size of this minute is not equal to 2, then I will concatenate 0 in front of it, else I will simply use the toString method to get the string out of this integer, and I will simply push into a result by separating this by the colon, and simply result. So time complexity will be constant because I know the range. So something like this, 11 into 59 and to count into 32. Yeah, so guys, if you like this video, please subscribe to the channel, comment and like this video. Thanks a lot.